radius of the S cubic. This is equation 2. Okay? Then we go forward for the steady state. So the steady state, we say that substitute equation 2 into equation 1. So if that's the case, you say that density of the S is equal to mass of the S that we have already determined it. Then we divide by the volume of the S, which is equal to 4/3 pi r radius of the S cubic. Right? So this is becoming sublimate. So this will make a 3 mass of the S divided by 4 pi radius of the S cube. So the formula now, because the question asks us to write the formula of determining the density of the S, we have obtained the formula of determining the density of the S. I like physics because it teaches me the properties of the matters which are very small, and then it also teach how to think about the largest things in the world, like the S or the universe. Density of the S, right? This is equal to 3 times mass of the S over 4 pi radius of the S cube, right? So then we go to another section that we say number 4, or the force state. So we are going to compute what? Let us compute the value of what? The value of density of the S. Okay? So the value of the density of the S, in order for us to determine the values of density of S, we have to know the values of the constants. The first constant, we say that mass of the S is equal to what? 6 exponent 24. I told you at the beginnings of this lecture. Radius of the S, I've already also mentioned. Radius of the S, we say it is 6.4 exponent 6 meter. Those are the two constants that we need. Pi. Somebody is asking himself or herself, what the value of pi? Hey, you forgot. Let me remind you because I love you. So the value of pi is always 22/7, and this is equal to 3.214, etc., etc., etc. Right? So if that's the case, now we say that the density of the S is equal to 3 times 6 exponent 24 in kilogram divided by 4 pi. You will find pi in your scientific calculator. Then we multiply by what? Radius of the S, which is 6.4 exponent 26, and this one is cubic. But this, the unit is what? Meter cubic. So for that case, you can use your scientific calculator to determine what? Density of the S. You enjoy physics? So you can start with finding the denominator first. Depends to which technique is easier for you. So then we multiply by 4, multiply by shift pi. That's the denominator. Then we have 6 exponent 24 over the response. Then multiply by 3. Okay? So the density of the S is 5.464 exponent 3. So the density of the S is 5.46, then exponent 20, exponent 3. The unit is kilogram per meter cube. So in gravitations, estimations are allowed to be taken into consideration. So we want to write this into significant figures, right? So it means into significant figures we have to estimate. So if we estimate this 60, then we'll get 5, then exponent 30, 3 kilogram per meter cube. So therefore, we have already answered the question that you've been asked. So we say that density of the S is equal to 5.5 exponent what? Exponent 3 kilogram per meter cube. But also this is equal to 5,500 kilogram per meter cube. Right? So therefore we say that the density of the S is 5,500 kilogram per meter cube. The response. Okay, that's all about the derivation of the formula determining mass of the S, and also we say that determinations of the mass of the S, and I taught you how to write the formula of determining the density of the S, and how we can compute this, the final point that I've taught you, how we can compute or we can obtain the density of the S. So now, those are the two applications of Newton's universal gravitation. Now, let me take you to the third applications of Newton's universal gravitational. And these third applications, we say that to derive, and derive the formula. Derive the formula of mass of the sun, with the homework I left in lecture 2, mass of the sun, and use it determine its mass. So this is another important application of Newton's universal gravitational law. So in case of the sun, we have to take consideration that now we have the S that revolving around the sun. So the question is, derive. These are the nectar questions they used to ask these questions, which are a little bit tricky if you're not well prepared. Formula of determining form of determining what? The mass of the sun, and determine its mass, or the mass of the sun. So this is the correction for the homework 1. Homework 2. Right? So if you did it, let us do correction together and see whether you are right or you are wrong. If you didn't do, please pause the video, go back to lecture 1 first, to lecture 2. Okay, so we say that the first step here, in case we consider sun, we don't have satellites, maybe communication satellites that revolve in the sun. Only the planets are the ones that revolve in the sun. So Newton said that the first step, consider the S that you are living, S is mass MA revolving the sun, okay, in a period of a year. The period of a year. When you say a year, this is 365 days. So let us consider the S as one of the planets that revolve in the sun. So our focus is onto the S. Okay, so then this is a circular orbit, just like assumption. This is sun, this is the S. Add the S. So what we notice that, for example, in this case, if the S is at this point, this is not sun, this is sun. And this, the S is orbit. That is the S's orbit. Suppose the mass of the sun is ms, and the mass of the S is me. Suppose the distance between mass of the sun and the S is equal to Rs. What do you mean of Rs? Rs means the distance from the sun to the S. So it's constant. Okay? Or that's the concept, or the first concept. Second step after the first step. Say that recall Newton's law or universal law of gravitation. State that the force of attraction is itself. The force of attraction is equal to what? Mass 1, mass 2, G, or gravity, of what? Over mean distance between the ear centers. But for this case, now we say that the force of attraction will be equal to what? Gravity mass of the S, mass of the sun, over guys, we are just starting, we are take consideration the force of attraction between the S and what? And the sun. So then the mean distance is what? The mean distance is called the radius, or the distance that the sun is from the Earth's surface. So this is the radius. This is the distance from the Earth's surface to the sun. So this one now is reached what? The first equation. The third step. So we said the third step right now, we say that you recall the concept of what? Concept of centripetal. Centripetal force. So recall in circular or recall it in rotational dynamics. So then what he said that we say that if that's the case now, we say that the weight, or we say that there's the centripetal force, which is Fc. And in that case, if the system is at equilibrium, we say that the centripetal force, or the force of attraction, is equal to what? Is equal to centripetal force. Centripetal force. So this centripetal force, we let it in circular, given us what? Mass times linear velocity square of what? Of r. Of r. So then we say that the centripetal force is equal to mass times linear velocity over radius. Again, we say that, but linear velocity is equal to angular velocity times radius. So if that's the case, you say that the centripetal force is equal to mass, then angular radius square over radius. So then this will make that the centripetal force remain is few items, which is mass, this one R cancelled, omega square times radius. Right? So that is what centripetal force. So mass omega square times radius. So this is equation what? Equation 2. Right? So what are we thinking in this form of centripetal? Right? What are we seeking? We are just seeking what? Or let us equate, and then so we'll deal with it later. So this is the step what? The force system. The first step we say that equate the centripetal force and what? Force of attraction. So they are equal. So we say that the force of attraction is equal to force of centripetal, and then this is equal to what? We found it there. Mass omega square r. Okay. So again that we said that if you want to equate, we say that equate equation 1, so we want to equate that equation 1 is equal to equation 2. So we say that the force of attraction is gravitational constant, mass of the S. But what is revolving around the sun? A body or what? S. So if it is S, then this mass is mass of the S, because it's the body that passes through its orbit. Are we together? Okay. So this is times mass of the S. That's mass of the sun. Divided by radius of the sun, or distance from the S to the sun square. And then this one is equal to, even this is mass of the S. Mass of the S, radius of the S, angular square, angular square. So the centripetal force, you say that this is the mass of the S, omega square times R. Okay? So in that case, now we see some like contents, and then we have here universal gravitational constant. That's mass of the sun, radius of the sun square, or distance from the S to the sun. And then we say that yes, those are the quantities that will remain there. Again, the stuff at this point, okay, we can make the mass of the sun the subject. It's a little bit tricky to find. So the best way we say that we go for the fifth step. The fifth step, we say that from the fact that angular velocity is equal to the ratio of angular displacement of what? Time. Right? So this is the angular velocity. But when a body is orbiting, for example, this body, the S there, is orbiting around the sun, then, and in that case, you say that this is 2 pi over period t. Right? So we say that omega is equal to 2 pi over t. So then this is equation what? A simplification, this is equation 3. This is equation 4. So if we take the value of equation 4 and substitute in equation 3, then we'll get universal gravitational constant, mass of the sun. Then we say that sorry, this is an S, radius of the sun, distance from the sun to the S. So then this is radius of the sun square is equal to twice pi over period square times 30 times radius, or the distance. So if that the case, you say that the universal gravitational constant mass of the sun, radius of the sun, is equal to 4 pi square over period square times radius. But what is the meanings of this radius in case of centripetal force? This is radius of the sun, right? Radius of the sun, radius of the sun. This is the radius of the sun, radius of the sun. Then, yeah. Okay. So if that's the case now, we say that our aim is to find this mass of the sun, and at least that now we have important parameters. So we go for the sixth step. Make the mass of the sun the subject. So if you make the mass of the sun the subject, we say that you have G, mass of the sun, radius of the sun, or distance from the sun to the S. Then this is equal to 4 pi square T square, then R for the sun. Okay. So then what we say, we are looking for this. So you have to multiply by radius of the sun to both sides. So multiply by radius of the sun to both sides. So there we have gravitational constant. Then times 4 pi square radius of the sun cube of what? Over period of the S. Right? So then we are looking mass of what of the sun. So you have G divided by G. So G and G cancel. Mass of the sun is equal to what? 4 pi R, radius of the sun cube of what? Period of the S to complete one revolution times universal gravitational constant. According to your geography, what the period for maybe a planet, for example the S, revolve around the sun and complete its circulation? 365. So then the formula now, say mass of the sun, which is ms, this will be, we can find it if you know the distance from S to the sun. The distance from there, S to the sun square, divided by what? No, cubic, sorry, not square. Gravitational constant and period square. We have the pi square there. Ah, okay, the pi square. Here I forgot to put square. And here I forgot square. Okay. So then this is the formula that you have been deriving. So we've been deriving this formula and finally we form. So just to clarify, because this is the homework that I gave you. So if you check first of all the formula, have you got it? No. So 4 pi square radius, this is not radius of the sun. this is the distance that, for example, this is the orbit for the S, right? Let me explain you about RS. And this is the S. So suppose that this is the S revolving around the sun, right? So if you say the radius of the sun, for example, if the sun like this one, then it will be the distance from the center of the sun to its circumference, right? But it's not like that one. So if this is the sun, RS, it's a distance from where? From the sun to the S. So this one is what you call the RS. It's a distance. It's not the radius of the sun. Don't confuse it. It's a distance. And then divided by what? Universal gravitational constant, G. And then this is the period for the Earth to complete one revolution. So the second part of the question, that after deriving the formula, then we have to use it to what? To determine the mass of what? Of the sun, and then we click the buttons and go to other concepts. Okay? So, to do so, we say that in order to determine what? In order to determine the mass of what? Of the sun. Okay? The mass of the sun, not the sun. If I've been writing sun, that's the error. But the mass of the sun. And you say that we need to say that the values of the universal constants have to be given. Have to be what? Given. What are the values of these universal constants? The first value is the distance from S to, remember that RS, this is distance from where? Let me write it for you. From the S surface. From the S surface to what? To the sun. Remember that I said RS is not the radius of the sun. Radius of the sun, we learn or we know the radius of the sun in case that we are learning the Stefan's law in determining the temperature of the sun. But in this case, we will never use the radius of the sun in all the concepts of gravitational mechanics. Right? So we need the value of this RS. It is 1.5 exponent, how much? 1.5 exponent 11 meter. 11 meter. So again, another constant is what? Universal gravitational constant, which is 6.67 exponent negative what? 11 Newton kilogram square meter square. Again, we need the value of what? Of period. T is 10 for what? Period for the S, right? For the S to complete what? One revolution. One revolution. So what the period? How long does S spend to revolve around the sun? How many days? Tell me please in the comment section. How many days? 360. 365 days. So remember that the units of universal gravitational constant, especially newtons, I told you that 1 newtons is equal to 1 kilograms meter per second square, right? So it means that all the units of other gravitational constant are in the year SI unit. So days is not a unit of time. What is unit of time? Seconds. So you have to change this number of days into seconds. How? We know that 1 day is equal to what? 24. Yeah, so this is called which step now? We said, or which step? I think that this is the 5th step, if I'm not mistaken. 1 day is equal to 40 hours. And then 1 hour is equal to 60 minutes. And hence we know that 1 minute is equal to 60 seconds. Right? So we say that a day